Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve next question, question number 16, 26 of question number 26 of the JEE Mains Physics paper 2016. So let us start with the question 26. Students, let us solve the next question. The next question says a pipe open at both ends has a fundamental frequency F in air. This is a pipe open at both ends. Suppose that this has a length L and in open organ pipe the fundamental frequency is given by V by 2L. This all of you must have known. So this is the expression for the fundamental frequency in open pipe. Because this has to be an antinode over here, this has to be an antinode over there because they're open ends, and here in the middle there will be node. So this sort of wave is formed. And how do you get this? Because we know that frequency is velocity upon the wavelength, and antinode and node, this is node, and distance between antinode and node is lambda by 4. Here it is lambda by 4, here it is also lambda by 4. So between antinode and antinode it is lambda by 2. So that means this length accommodates lambda by 2. Lambda by 2 wave is formed in the length L, that implies lambda is 2L. So substituting 2L here is V by 2L, that is the fundamental frequency. So the fundamental frequency in open tube is V upon 12, where V is the speed of sound and L is the length of the tube. This is given as F. In a question, this is given as F. This is first equation that we are getting. The second case, the pipe is dipped vertically in water. This pipe is dipped vertically in water. So if I dip this in water vertically, so that half of it is in water. So if I fill it half the length in water, then this one is left only half the length. So this length will be L by 2. The fundamental frequency of the air column is now, because of water, this behaves like a closed end. So this is a example of closed organ pipe. In closed organ pipe, the fundamental frequency Fc is given by V by 4L, because if we have a pipe closed at one end and length is L, this is how the stationary wave is formed. This is node and this is antinode, and the distance between node and antinode is lambda divided by 4. This lambda divided 4 is equal to the length L of the tube. So lambda by 4 is L. So from here lambda is 4L. So frequency for closed tube, fundamental frequency in closed tube is V by lambda, that is V by 4L. So this is how you get the fundamental frequency V by 4L. Now in this situation, this is a general expression, and in the given situation, the tube has been dipped half in water and half in air. So the length now is reduced to L by 2, and this is your node, and this is your antinode, and this is your node. So in this case, the distance between antinode and node is here is lambda by 4. So this lambda by 4 is accommodating lambda by L by 2 length accommodates lambda by 4. So I will write L as or lambda as L12, lambda as 12. Okay, lambda as, if you multiply that to this side, lambda is 12. So if I want to find the fundamental frequency, it is V by lambda, that is 12. I will get V by 12, or I can substitute this length because the length is reduced to half. If this becomes half, then this is 12. So this is what I'm getting if the tube is made half the length and the open tube is converted to the closed tube. So this is equation number 2. You can compare this equation 1, which is V by 12 is F. Then here also you are getting V by 12, that must be F. So what we are getting is from 1 and 2, the fundamental frequency in open tube dipped half in water is also F. Is also F. So in this situation we have the fundamental frequency of air column is now it will be 4. That is the answer to this question. Okay, thank you.